Hello, everyone, and we are still carrying on with the next talk for today. And I'd like to introduce Clemens Hübner, who is doing built-in security, secure web apps using modern browser features. Clemens studied mathematics and computer science and graduated with a master's thesis on security in agile development models. After working as a software developer and in penetration testing, he joined Innovex in 2018 as a software security engineer. Today, he supports development projects at the conception and implementation level, trains colleagues and advisors on DevSecOps. Clemens, thank you very much, and I'll let you take it away from here.
Yeah, thank you very much for the introduction. So welcome everybody for the second half of our summit today. Very happy to talk to you after the break. Hope everyone found back to my talk now. So yeah, I was already introduced. Just two quick words about me. I'm Clemens. Feel free to contact me on Twitter or via email. I'm from Germany, located here in Munich, where I work at Innovex. And yeah, it was already mentioned, I work with software development teams and try to build secure software together with them and try to hack them myself before other people do so. And during my work and my research, I often got in contact with browsers. We often build web applications, and that's where I want to talk about with you today. So browsers are the central entrance to the internet today. In these pandemic times, I guess they are even more than before. So a lot of things in the internet works through browsers. Of course, you can also use Twitter via curl, I guess, but it's a lot more convenient using a browser. And that's why browsers are so important for web security. And to give you a short idea, so in a classic architecture of a web app, we have a server and we have a client, and they talk to each other. And I often do security trainings for developers. And when we talk about validation or authorization, I always say, don't trust the client. Security measures have to be taken in the server because, yeah, you cannot really control the client. But there are some things you want to do in the browser, or it's, yeah, nice to do so in the browser. For example, everything that has to do with UI, UX. So of course you can just give the user feedback on his form inputs after he sent it, and he has to restart again. But it's a lot more convenient to check some things in the browser, or you want to access device features. So just like my webcam I'm using right now through my browser to talk to you. And of course, some security-related stuff as well. So browsers may help us authenticate a user in a strong way. Or we want to do end-to-end encryption. So it's not sufficient that we encrypt things on the server maybe, but we want to do so in the client. So we have an end-to-end channel of encryption. And of course, yeah, everything that's happening on the client is just as important as things that are happening on the server. So we want to have some kind of logging, monitoring, reporting there. So these are some things we might want to do in the browser. And if we want to develop things for client side, we are often limited to JavaScript, sure. You know this JavaScript, there's this tale that it was designed in 10 days. And of course, the language that was designed then is not what we have today. But of course, we're sticking to JavaScript if we want to implement client-side web apps. And we have some problems with performance or it's, file handling, for example. That's things that's not so good with JavaScript. And we have all the problems with third-party dependencies. We heard this some talks ago, and I think there might be a talk later on again on this topic. And if we talk about clients, we have broad diversity of different browser versions, browser vendors, different system they are running on, and of course also devices they are running on. So these environments are hard to control. We do not know exactly what we are running on with our client side, and maybe it's even a compromised environment. We have our web app running. So browsers have to deal a lot with security. You all know the basic security measures in browsers, for example, the same origin policy, or all the handling of encrypted communication using HTTPS, with certificate management and all stuff like that. Cookie handling, of course, is something very crucial to security done by the browsers, and all the security headers that we can use to secure our websites even more. But that's not what I want to talk about today, or not only, but I want to talk about some fancy new features browsers can help us to build in our client web apps. And we want to focus on 3 of them today, and I want to give you a short overview over how to do them. So the first of these will be strong authentication. So how can we authenticate users in the browser in a better way than we are doing it today? Second one will be end-to-end encryption. I just mentioned that 1 minute ago. And then the last one will be client-side reporting. But let's start with strong authentication. So if we talk about authentication today, it's all about username and passwords. So if you Google for authentication images, you find stuff like that. So it's always a username and a password field. That's how authentication is done today. Sometimes it's getting more common. That's great. We have a second factor like a push notification or time-based or a token. But that's additional and not used everywhere. But the center is always sticking to a password as the authentication factor. And the password, of course, is something you have to remember. And human brains are not good in remembering stuff, especially if it has to be something random. Like a secure password. So if you want to use a secure password, it has to be random, it has to be long, and it has to be different for each client or website you are using, account you are using. So that's something brains are not good at. Of course, you can use password managers. I recommend that. But even then, you have to stick with something you have to keep in your brain. In this case, the password manager's master password. And of course, on the developer side, if you talk about handling passwords, you have to transmit and store them securely. And I can tell you from my experience in auditing source code, hashing passwords is something that is not done correctly all the time. So that's a big issue there. So maybe we can not stick to some authentication factors that are knowledge-based, like passwords, but to other factors, for example, stuff you have or stuff you are. For example, these hardware tokens. I have one YubiKey here, but there are other systems as well. That's something I possess, I own here, and no one can pretend to have the same key, or something you have, something you are, biometrics, for example, fingerprints, or face recognition. So these factors might be better compatible with human users. So let's see how we can use this in our web apps. And that's where the API comes in I want to show you today. But let's start with a quick demo. I'm afraid it's in German, but I guess we will not be disturbed by that. So this is our login form we will use later. And what's different here is it only has an email field and no password field. That's different to the authentication I have shown you before. But first we have to register, and that's where the API comes in I want to show you today. So let's just register here with my name and my last name. And you'll see I'm in Chrome. It's a normal web page. And if I click register here, some kind of pop-up opens. And if I now use my YubiKey, my hardware token, put it in, touch it. Oh, I was a bit too slow. The timeout ran into, sorry for that. Let's start again. So I have to be quicker. Let's do it again. That's not how it was intended. Okay. That's the problem with live demos. So let's see if I can use the login I just prepared up front. So if I want to log in here, I have to insert my YubiKey as well. Let's do this here. And we click on login. And this does not work right now. Okay, so let's have a look at how this should be done later on. So the API I wanted to show you here is WebAuthn. WebAuthn is a browser API that can be used to communicate with external authenticators, just like my YubiKey here. Or also internal authenticators, like, for example, the password, the fingerprint sensor on my MacBook, or other internal authenticators. So this API is built into my browser, and it allows me to register and log in using hardware tokens instead of passwords, or other authenticators instead of my password. And therefore, WebAuthn has two different ceremonies. So the first one is registration. So here it allows the web app to communicate through this browser API with the authenticator, create a public key credential, which can be stored on the server. And when authenticating the user, we can prove that we possess this authenticator in a challenge response mechanism. So WebAuthn is not so brand new. It was published as a v3c recommendation in March 2019. So it's over 2 years old now. There was a new level this year. And the great thing is it's widely spread across the common browsers we are using today. These are the numbers from yesterday. So all the major browsers allow to use this API in our JavaScript client code. So we are able to access authenticators besides through this browser API in our JavaScript code. So that was a very quick intro to WebAuthn. It's widely implemented by the browsers, but not so widely implemented by web pages. So this is something that has to be improved in the future. And also it's just covers the authentication and the registration of a user. So all the processes you need around that, for example, how to what to do if a user loses his YubiKey, etc. Has to be done through your own processes and your own implementations. And of course, I guess some of you might be familiar with these YubiKeys, but if I give one of these to my grandmother, they are not really familiar how to use them. So that's something, I guess, what's the main reason why it's not that much spread right now. You have to educate and guide your users and make sure they understand it correctly and use it in a right way. So let's continue with a second browser API you can use for our second use case, end-to-end encryption, or maybe even end-to-end cryptography. If you want to do cryptography in the browser, that's quite hard. We had the limitations of JavaScript before. There are no native implementations accessible for cryptographic operations. For example, you cannot generate real cryptographically random numbers. And there are a wide range of libraries if you want to use one of these with different qualities. So you have to rely on them if you want to add cryptography to your client-side web app. And of course, you are restricted to the performance of JavaScript, which is getting better, but especially for cryptographic operations where you want to encrypt larger files or something like that, it's not so good. So there's this great quote of Bruce Schneier that anyone can design a cipher that he himself cannot break, but of course it's always possible that someone else can break it, and that's the reason why you never should do your own cryptography and rely on vetted algorithms and that are publicly tested and audited. And that's why you should be very carefully using using cryptography in JavaScript, for example. But there are some use cases we can think about why we want to do cryptography not only in our backend, but also in the front end. I just mentioned it. We maybe want to do end-to-end encryption for a chat, for example, or for cloud storage. So we do not want to rely on the encryption of the server, but want to make sure this is done by the browser. We want to make better authentication methods. We want to maybe cache data locally and want to make sure that it is integrity protected. And we can see if someone tampered with this data. So that's all use cases for client-side cryptography. And that's also a field where the browsers have decided to bring an API to JavaScript developers that can be used for doing cryptography in JavaScript in the browser. And that's the WebCrypto API. That's a platform-independent JavaScript API accessible through JavaScript, and it allows to access low-level implemented cryptographic operations, for example, generating secure random numbers, generating and handling keys for all different crypto systems, symmetric and asymmetric ones, for example, AES or RSA, etc. These are all provided through WebCrypto API natively in the browser. And let's have a look on how this is implemented by the browsers. That's even a little bit better than the WebAuthn I just showed you before. So all the major browsers implement it besides the Internet Explorer, but let's skip this problem for now. But if you have a look at the user percentage globally, you have more than 95% that are already using a browser implementing the web cryptography API. So this allows you to access cryptographic operations without using a third-party library. It is very performant to do this using this API. I made some benchmarks for myself, and it was around a factor 10 to encrypt and decrypt files using this API. So that's something you can really see if you use it. And there are a lot of stuff how you can handle keys in the browser context. So this integrates very well in the browser and its storage possibilities. But still, cryptography is something that should be handled carefully. So even if you now do not have to decide on a library, you still have to decide on which cryptographic algorithms you should use, and what parameters are important there. So that's nothing one should take too easy, but should consult an expert on this. And of course, if you do such sensitive operations in your client web app, there's the even greater need to secure your web app even more than it's needed right now. So if you do stuff in the client, you have to make sure you have no other vulnerabilities in your client, because that will be a problem here. So that's the second API in our quick rush through modern browser features. And the third use case I want to share with you is client-side reporting. So I think all of you are familiar with logging in the backend and then on the server, and but that's not the only part of our web application. Of course, we have the client side, and I already discussed the diversity of browsers and systems and devices we have out there. And if you run a web app in production, errors and crashes will happen. That's for sure. So it's interesting to see what happens on the client, but it's also very hard to see this or to obtain this information from the client. And that's where the reporting API comes in. For example, if you have CSP policy on your website, you want to get notified if some violations happen there, because maybe it's not a real violation, but you just forgot to enter some sites in your directive. And oh, sorry, that's too fast. So that's something the reporting API covers. Beside that, it's about network error logging or deprecation reports that may be also interesting from a security perspective. And later on, they plan to add, for example, crash reports. So when your client-side web app crashes completely, that's very hard to obtain if the browser is not helping you with that, or other violations. And the reporting API consists of two different interfaces. One is the report to header. That's an HTTP header. You can define for defining endpoints the browser uses for sending these reports about the violations I just told you to a backend you have to run or to provide. And these reports are delivered by the browser if something happens out of band with a special application type. So that's one interface. The other interface is a bit more into your JavaScript code. So it's a JavaScript API, just as the other two I described before. And it allows to capture and handle reports that are happening in the web app in your client code and handle with this. So these are the two interfaces. And If you choose to use the first header and want to get reports about, for example, CSP violations or network errors, you need to define an endpoint. First of all, you might think, yeah, I'm a web developer. I can implement my own report endpoint. Yeah, we tried this as well, but you might get a little bit of too much information there and have to think about how to cluster it and to analyze it. So sometimes it's better to not implement it yourself, but use a tool. For example, Sentry is a free tool, or you can run it for free on your own infrastructure. So did we. And it supports a lot of reports, so you can receive there and analyze, when you have time. There are other providers for that, for example, Report URI, or if you are only looking at CSP violations, you can have a look at CSP error, for example, that are providers for these endpoints where you can receive these reports. So the reporting API is also developed through the V3C, but it's not standard yet. So it's an editor's draft right now since February, and it's not that much implemented in the browsers out there. So it's mainly driven by Google. So Chrome is already implementing it. But for example, in Firefox, it's hidden through behind a feature flag, and in other browsers, it's still not available for usage. So that's something experimental, I would say. You can have a look at this, but it's not really ready for production. So that's what is important about the reporting API. Not a real standard right now. There might be changes. It's mostly driven by Google, and they are known for make changes if they want to. But if you decide to use it, it really gives you helpful insights into your application at the user on their system that you might not get if you do not do so. So these are the three browser APIs I wanted to share with you today. So we saw how to do a strong authentication using WebAuthn. We saw the Web Crypto API for end-to-end encryption or other cryptography in the client. And we saw in the end the reporting API that allows us to do client-side reporting. And after all, we see a strong trend to standardize these features. So the browsers are trying to standardize these things, so you do not have to think that much about, is this possible in this browser? How do I handle this in Firefox? How do I handle this in Chrome? But of course, especially if it comes to UI, there are small differences in the implementations you have to look at. So that's the burden you have as a front-end developer. You always have to look at the different implementations of the browsers. And of course, that's the last remark I want to give to you. If you decide to use this possibilities in the client and you decide to implement more features in your client, you have the obligation to even more secure the client, of course, and analyze for the threat model of your client and make sure that it is secure in every thinkable way. So I will share this slides later on, so you can get some additional resources here out of this last slide. So just have a look at my Twitter account. That's also the best way to reach out to me. So if you have any questions or remarks, I'm happy if you contact me. And then that's it from my side. Thank you very much for listening. And I'm open for any questions.
Thank you so much, Clemens. I haven't seen any questions coming in on the YouTube channel, but please do jump onto the Ask Slack as well. And if you guys have questions for Clemens, there, as he said, there's his Twitter handle. Reach out to him on Twitter, and do keep the conversations going. I really appreciate it. Thank you, Clemens. I appreciate your time.
Thank you. See you. Bye-bye.
Bye. Also want to just say a quick thank you to Sneak, who are our platinum sponsor for today's Developer Days. Thank you very much for helping us to make this happen. And with that, I will see you guys on the next session, which will be starting shortly. Thank you.